Hey everybody, in this lesson we're going to be talking about solving quadratics in vertex form by using square roots. Now, we've already solved quadratics in the past by using square roots. The only thing that is brand new here that you guys have not seen before is that we're talking about solving quadratics in vertex form. So I'm going to go ahead and talk to you guys a little bit about what that is and what that means and how does that look like. So as you've seen in the past, quadratic equation in standard form is ax squared plus bx plus c. It's called standard form because it gives you some critical values. It gives you the values of A, it gives you the value of B and C right away. And then with these values, you can use those values to try to graph the quadratic equation or to try to solve the quadratic equation by using those values of A, B, and C. So the other type of way that we can write a quadratic equation or expression is called vertex form. Now, vertex form looks like this. You haven't seen that at all so far, but basically the vertex form for a quadratic, it looks like this. It gives you two things. It gives you the value of A, which is the exact same A that you guys saw up there. So that value of A gives some pieces of information, which we'll talk about in the future. But it also gives you the values of H and K. Now, the values of H and K, if you put those things together, it actually gives you what is called the vertex. So the vertex is just a point, and the point is H comma K. Why did they pick H comma K? I don't know. It's just I think X and Y were already overused, so they just decided to use two different letters. So this is also known as the maximum point or the minimum point of the parabola. And the parabola is that shape that you guys have seen before probably in a lot of these problems when you've checked with Desmos. A parabola is basically just a graph that looks kind of like the letter U, either going upwards or going downwards, but essentially it's the same shape, that letter U. The vertex is actually the point that is either at the very, very top or at the very, very bottom of that shape. So this is also known as the minimum point or the maximum point. But no matter how you call it, whether it's called the minimum or the maximum, at the end of the day, this point is called the vertex of that parabola. So the vertex is also known as the maximum point or the minimum point of a parabola. Okay, so that is why this is called the vertex form, because the vertex kind of gives you that little point, either the top or the bottom of the parabola. Don't worry too much about that today. We're not going to talk about vertex or vertices. In this lesson, we're going to be talking about that in the future when we actually go over graphing parabolas. For now, all you really need to worry about is how do we solve a quadratic when it's set in vertex form. So all we need to do is solve. So I'm going to go ahead and just refresh your memory on what we should already know on solving equations in general when we talked about solving for emojis. So let's say I wanted to solve these four equations, and I'm solving for them in terms of emojis, and then we'll come back to it in terms of the quadratic formulas that we actually need to solve. So if I wanted to solve this first one, all I have to do to solve this is divide by 5 on both sides. I'm going to be left with this little emoji squared is equal to 5 divided by 5, which gives me 1. Then if I want to solve this by getting rid of that square, I have to take the square root of both sides. Now, just a reminder, whenever you take the square root of something, there is actually two different versions. There is the positive and the negative of that number. So positive, negative, square root of 1, which means that the answers are, that came out kind of weird. The answers are happy face emoji is equal to plus or minus 1, which means there is actually two solutions, x equals 1 or x equals negative 1. Okay, so that'll be my first answer. I can do the same thing for the other ones, right? So if I want to get the emoji by itself, I would have to add 8 to both sides. Add 8 for this. I would drop down whatever's left. 4 multiplied by the emoji squared is equal to positive 8. Then I have to divide by 4 on both sides. Divide by 4, divide by 4. This crosses out. I'm left with the emoji squared is equal to 2. And then finally, if I want to get rid of that square, I have to take the square root of both sides. Once again, remember, when you take the square root, you have to include that plus or minus because there's two possibilities, right? So it's going to be final answer plus or minus the square root of 2. Now, since I know that I can't simplify that any further, I'm basically done here because I can't break the 2 anymore. Okay, the third one, same idea. So we're going to try to solve this for the emoji. So we're going to draw the wall. We're going to be subtracting 4 on both sides, minus 4, minus 4. I'm going to drop down everything else. So 2 multiplied by the emoji squared is equal to -4. Then I have to divide by 2 on both sides. So divide this by 2, divide this by 2. That crosses out. I'm left with emoji squared is equal to -2. If I want to keep on solving, so I got to get rid of that square on top, right? So I take the square root here. So I am left with the happy face emoji, or the emoji, right, is equal to the square root of a -2. Uh-oh, wait a minute. Remember, we can never take the square root of a negative number, right? So two numbers that multiply together that are the same will never give you a negative answer. So in this case, this is not going to be a happy face emoji. It's actually going to be a sad face emoji because there is no solution. So remember, you cannot take the square root of a negative number, so we can't solve it. The last one that I have for you guys before actually moving to some numbers is this one right here. All we have to do to solve for the emoji is take the square root of both sides, right? If I take the square root of both sides, I have the emoji here, not squared anymore, is equal to plus or minus the square root of 9/3. Don't forget the plus or minus, very important. So that emoji, happy face emoji, is equal to this. Now just remember that whenever I have the square root of a fraction, I can split that radical into the top and the bottom. It'll be the exact same thing. So I can say that this is the same thing as saying plus or minus square root of 9 divided by the square root of 3. So I just took that radical and split it up into the top and the bottom. Same answer. So when I do that, my happy face emoji is equal to plus or minus. On top, the square root of 9 would actually give me 3, right? So that's a nice answer. So it'll be 3 on top divided by radical 3. So I would be done, except for the fact that if you leave a radical on the bottom of a fraction, we already established that that is considered not simplified. So I kind of sort of have to keep going and then rationalize that denominator. So if you remember from the last lesson, I can just multiply top and bottom by the square root of 3, right? That way the radical disappears on the bottom. So the happy face would actually be equal to, on top, plus or minus 3 radical 3. And on the bottom, I'm left with just 3, right? Because the square root and the square root go away. So it's just going to be a 3 on the bottom. Since I can go a little bit further, I know that 3 divided by 3 would actually cancel out. So my final answer would actually be the positive and the negative version of radical 3. So emoji, happy face emoji equals plus or minus square root of 3. So the positive version and the negative version of the square root of 3. It's some random decimal. If you punch that into the calculator, it'll actually give you the number, but it's plus or minus square root of 3. Okay, now that you have refreshed your memory of how to solve emojis, let's actually talk about how to solve quadratic equations in vertex form. These are the steps you absolutely need to remember. So step number 1 is you have to isolate the parentheses in the quadratic equation. So we're going to treat this the same way that we're going to treat the emojis, basically get the parentheses by itself. Step 2, we have to take the square root of both sides, if possible. Remember that if we can't take the square root of a negative number, so that's why I'm putting if possible there. And also don't forget the plus or minus, right? So when you take the square root of something, you have a plus or minus because you're going to have two different equations. Step 3 is you're going to split it into two separate equations. And then finally, we just have to solve each one. And that will give you your roots, which are also known as the solutions of the quadratic equation. I'm going to go ahead and check the answers with Desmos. I already have the answers ready to go. So you guys can see that it actually does match up if you want to check your work. So jumping right into example number 1. So example 1 says solve the quadratic equation by using square roots. Simplify the radical, if you can. And then verify your answer with Desmos. So verify the answer with Desmos. That way if you want to make sure you did it correctly. Now remember, for the radicals in Desmos, you have to convert them into decimals because Desmos, for whatever reason, doesn't like to put the answer as a decimal instead of a radical. So just, you have to use calculator to double check. Okay, so the first example, if I want to get the parentheses by itself, remember that's the first step. We want to get the parentheses by itself. Same exact thing as the emoji problem, right? All I have to do is divide by 5 on both sides. So draw the wall, divide by 5, divide by 5. This cancels out. I'm going to be getting as my final answer x plus 7, or simplified answer, sorry, x plus 7 squared is equal to 1. Okay, next step, still want to get the parentheses by itself, right? Kind of like the same thing that we do with the emojis. So I would take the square root of both sides. So take the square root of this side, take the square root of this side. So I'm left with x plus 7 is equal to The square root of 1 is just 1, so I'm going to be left with plus or minus. Don't forget the plus or minus. There are two answers. Plus or minus 1. So that's the gist of it. The rest you actually know how to do. So this is actually two different equations given to you in one, right? So the two different equations that are given to you are x plus 7 is equal to the positive version of that 1, and then x plus 7 is equal to the negative version of that 1. All we have to do now is solve each one of these equations, and then we're good to go. We solved our two roots. So we draw the wall, subtract 7 on both sides, subtract 7, subtract 7. I'm going to be left with x is equal to negative 6. This is one of my roots. Do the same thing for the other side. Draw the wall, subtract 7 on both sides, minus 7, minus 7. I'm left with my second root, which is equal to negative 8. X equals negative 8. So when I check my answer with Desmos, right, I'm gonna set everything equal to 0 and then check it. So you would not plug in this exactly. You would set it equal to 0, right? Which means you would write something like this: 5x plus 7 squared minus 5 equals 0. You would actually graph this part into Desmos, which is exactly what I did. So I have 5 parentheses x plus 7 squared minus 5, right, which was equal to 0. And my two answers, look at that. We have the parabolic shape, so it's a parabola, right? My two answers are negative 8 and negative 6. So you could always check your work if you are wondering if you're doing it right or not. X equals negative 8 and x equals negative 6 for the first one, which is the exact same thing that we got, right? X equals negative 8, x equals negative 6. All right, example number 2. Same thing. Solve the quadratic equation by using square roots. Simplify the radical and leave it in radical form. Verify your answer with Desmos if you can. So I want to solve this. Same thing. The thing that I want to get by itself is the parentheses, right? So I want to get that parentheses by itself first before anything else. So I'm going to go ahead and just add 8 to both sides. Plus 8 plus 8, right? I'm left with 4 parentheses x minus 3 squared is equal to this 8 and negative 8 cancel out. That'll just give me 8 on the other side. Next, I want to divide by 4 on both sides. Divide this by 4, divide this by 4. This cancels out. I get x minus 3 squared is equal to 2. And then I want to get rid of that square so I can get the parentheses by itself. Again, all the purpose of this is just getting the parentheses alone on one side. Kind of like the emoji. Since I don't have the parentheses by itself, I have to take the square root of both sides because I have a square still, right? Take the square root of this side, take the square root of this side. So I'm left with x minus 3 by itself. Great, that's what I wanted. Is equal to plus or minus, don't forget the plus or minus, because anytime you take the square root, you have a plus or minus, square root of 2. So that is the hard part. All you have to do now is break it up into two equations, because plus or minus means we actually have two separate equations, two separate numbers, right? So one of my equations is going to be x minus 3 is equal to the positive version of square root of 2. The other equation is going to be x minus 3 is going to be equal to the negative version of square root of 2, and then I have to solve each one. If I solve this one, I get x is equal to 3 positive square root of 2, as in we're going to add that whatever decimal number is. And then if I solve this side, I get x is equal to 3 minus square root of 2, and then this will be my second answer. Now, like I said, Desmos does not do radicals. However, you could always check your answer with the radical real quick. If I plug that into the calculator, let me just do it real quick. So just clear this. 2 square root of that. And then I'm going to add 3, right? So, oh, wrong thing. Yes, plus 3. Okay, so if I do the plus 3, all I have to do is add 3, and then I get equal to 4.41, right? So one of my answers should be 4.41. So let me go back and write that real quick. This one is x equals 4.41 as a decimal. If I do the same thing again for the other one, I'm going to get 2, take the square root of that, and then I'm going to make that negative. Actually, I have to do that first. So minus square root of 2. Well, it doesn't let me. Oh, I see. I'm using a different negative. So I need to use this one right here on the bottom. That makes sense. So negative 1.41 and then add 3. It's 1.585, which is about 1.59. So my second answer should be about 1.59, right? So x equals 1.59. So these are my two answers. They're the same thing as what I boxed, but this is actually what Desmos is going to tell me. So when I graph this with the graphing calculator, right, I'm going to be graphing it as is because it's already set equal to 0, so that's kind of great. So when I graph it, I get these two answers. So this is my parabolic shape. This is my parabola, right? So it's a U pointing upwards. It happens to cross the roots at these 2 points. And look, what do you know? One of the roots is 1.586 and the other one is 4.414. So these are actually the exact same roots that we got, right? So 1.58 and 4.14. And the exact same thing that we got here, 4.14 and 1.58. I think I probably wrote this backwards, but those are the answers, trust me. Okay, so example 3. Solve the quadratic equation by using square roots. Simplify the radical and leave it in radical form. Verify your answer with Desmos. So same exact thing. We want to get the parentheses by itself. So that means this, right? All I got to do to get rid of that square is take the square root of both sides. So I'm going to go ahead and do that. Take the square root of this side, take the square root of this side. I'm left with just the parentheses by itself, which I don't even need the parentheses anymore. X minus 1/2, right? It's on this side. And then I'm going to set that equal to, remember when you take the square root of something, you have to have that plus and the minus. So that's plus or minus square root of 3 over 2. Like we mentioned in the past, that square root of 3 over 2 can actually be split. So x minus 1/2 is equal to plus or minus square root of 3 on top divided by the square root of 2 on the bottom. So I can actually go ahead and simplify that fraction by rationalizing the denominator, right? So that denominator is not good for us because it is considered not simplified. So let's rationalize it by multiplying top and bottom here by square root of 2, square root of 2. That way it can be simplified a little further. So when I do that, I get x minus 1/2. I haven't messed with the left-hand side at all, so I'm just going to leave it alone. Is equal to plus or minus 3 times 2 would give me 6, so that'll be the square root of 6 on top. And on the bottom, I get the radical cancels out, so it's just 2. So it's square root of 6 over 2. Okay, finally, the next thing that I need to do is get the x by itself, so I have to add 1/2 to both sides. It looks kind of funky, I know, but that's all I'm doing is just adding 1/2 to this side. The 1/2 negative and 1/2 positive cancel. Whatever I do to one side, I have to do it to the other side, so I have to add 1/2 to this side as well. The great thing about this is that in order for us to add or subtract fractions, we have to have the same denominator, which we kind of already do, right? So the final answer for this will be x is equal to the square root of 6 plus 1. And then since we have the same denominator, we can just put it all over that denominator. So don't forget that square root of 6 had a plus or a minus, right? So this will be my final answer. Now, if it messes you up, because I don't like the way that it looks right now, if it looks kind of funky, I'm going to go ahead and just switch the order using the commutative property. I'm going to put the 1 in the front and the square root of 6 on the back. So I'm going to write 1. Ooh, that's an ugly one. So 1 plus or minus square root of 6 all divided by 2. Same answer, except that it's backwards on top. Okay, so these are my two answers. And I will count that as 100% correct in any math book. But for the sake of checking our answer with decimals, I have to convert this to a decimal. So I have to take the square root of 6, add 1, and then divide that by 2. So these are my two answers. So let's do that. So with the graphing calculator. So let's do first 1. Well, let's do square root of 6. So 6, take the square root of that. Okay, that's that. Plus 1. And then I'm going to divide that by 2. So I get 1.72 as my first answer. So one of my answers is 1.72. That was when I added it. Now when I subtract the square root of 6, let's see what I get. So same thing. Take 6, take the square root, make that negative, and then we're going to add 1, and then divide it by 2. So my second decimal is negative 0.72. So when I go back to my second answer, I get negative 0.72. So negative 0.72. Okay, so these are the exact same answers that I have here that I boxed, but I actually converted the square root of 6 into a decimal. And these are my two answers that I better get as my roots, right? So when I graph this with Desmos, it is not set equal to 0, right? We got to move that 3 over 2 to the other side. So what I actually write down is x minus 1 half squared minus 3 over 2, because that part is set equal to 0. That'll graph it in decimals, and it'll give me my two roots. This is the parabola that it gives me, so it should have two intersections. It should cross twice. The first intersection is here at negative 0.725, and the second intersection is here as 1.725. So our two answers that we got, right, the 1.72 and then 0.72 should be the exact same answers that we get with Desmos, which they are, right? So two answers were 1.72 and the negative 0.72. Perfect. So we know we're doing it right. Last example, and this is the last one just for comfort, just so you don't get tricked in the future, is what happens if you have an example in which you can't take the square root. So if I wanted to solve for the radical, for the parentheses on the left-hand side, I would normally do minus 4 on both sides, right? And then you get 2 parentheses, x minus 3 squared is equal to negative 4. We have to get the parentheses by itself. So in this case, we would divide by 2 on both sides, divide by 2, divide by 2. This goes away. Same thing here. I get x minus 3 squared is equal to negative 2. Then I have to take the square root of both sides, to the square root of this side, to the square root of this side. One problem though, as you have probably noticed by now, you cannot take the square root of a negative number. So in this case, x minus 3 would not, I didn't even write 3. So in this case, I cannot go on any further. There is actually no solution because I am not able to take the square root of a negative number, right? So this is the problem here, that negative 2, I can't take the square root of that. So we have no solution. So that's great. Let's work for you. What does that mean in terms of Desmos though? So if I actually graph this in Desmos, so 2 parentheses x minus 3 squared plus 4, that's already set equal to 0, so that's great. When I graph this, I get this graph, 2 x minus 3 squared plus 4. And this gives me a parabola, but the parabola is actually way above our x-axis, so it never actually intersects this x-intercept. Therefore, we have no roots. Since it never crosses the x-axis, that's why we have no solution. That's what that means. So I hope this video was helpful. I'll see you guys on the next one. Make sure you do the activity or the worksheet and turn that in. Thanks.